Right, this is Unit 4, Lesson 3, multiplying and dividing rational expressions. Our essential question is, how does understanding operations with fractions help you multiply and divide rational expressions? And here is our table of contents. Rational expressions. A rational expression is the quotient of two polynomials. The domain is all real numbers except those for which the denominator is equal to 0. So x squared divided by x squared minus 9, since the denominator cannot equal 0, x squared minus 9 cannot equal 0. So x squared cannot equal 9, which means x cannot equal 3 or negative 3. So the domain is all real numbers except 3 and negative 3. Write equivalent rational expressions. When are two rational expressions equivalent? Rational expressions can be simplified in a process that is similar to the process for simplifying rational numbers. So 12 divided by 16, I can rewrite that as 3 times 2 times 2 divided by 2 times 2 times 2 times 2. And then I can cross off. I can basically create groups of 1. So 3 divided by 2 times 2 over 2 times 2 over 2, which is the same thing as saying 3 divided by 2 times 2 times 1, or 3/4. By replacing quotients of common factors between the numerator and denominator with 1, you learn that 12/16 is equivalent to 3/4. Write equivalent rational expressions. Write an expression that is equivalent to x cubed minus 5x squared minus 24x divided by x cubed plus x squared minus 72x. So step 1 is to factor the numerator and denominator. In this case, I can factor x cubed minus 5x squared minus 24x by factoring out an x or taking out an x, and then factoring what's left over. The x squared minus 5x minus 24 factors to x minus 8 times x plus 3. The denominator x cubed plus x squared minus 72x, they all have an x in common, so I can factor that out. So I have x times x squared plus x minus 72. And then the x squared plus x minus 72 factors into x minus 8 times x plus 9. Step 2 is to find the domain of the rational expression. So the domain in this case is all real numbers except 0, because x can't equal 0, x minus 8 equals 0, or x equals 8, and x plus 9 equals 0, or x equals negative 9. Step 3 is to recognize that the ratio of the common factors in the numerator and denominator are equal to 0, or equal to 1. Okay. So they both have an x minus 8 in common in the numerator and denominator, and they both have an x in common in the numerator and denominator. So I'm left with x plus 3 over x plus 9. So that's the expression that's equivalent to x cubed minus 5x squared minus 24x divided by x cubed plus x squared minus 72x. Simplify a rational expression. What is the simplified form of the rational expression? What is the domain for which the identity between the two expressions is valid? 4 minus x squared divided by x squared plus 3x minus 10. A simplified form of a rational expression has no common factors other than 1 in the numerator and denominator. So step 1 is to factor the polynomials. So I'm going to factor my numerator. 4 minus x squared is the difference of perfect squares. So that's 2 minus x times 2 plus x. X squared plus 3x minus 10 factors to x minus 2 and x plus 5. I'm going to rewrite the numerator so that it looks something similar to what we've seen before. Okay. I can just rearrange the 2 plus x, but I can't just rearrange the 2 minus x. Well, I can, but it would be negative x plus 2. Step 2 is to identify the domain from the original expression. So the domain is all real numbers except 2 and negative 5. Okay. And you can see this because my denominator again is x minus 2 times x plus 5. So I set each of those factors equal to 0 and solve, which gives me my domain. Step 3 is to divide out common factors. So again, I rewrote that 2 minus x to be negative x minus 2. Okay, I can see that they both have an x minus 2 in common. So I can cancel them out. And I'm left with negative x plus 2 divided by x plus 5, which is its simplest form for all real numbers except 2 and negative 5. Multiply rational expressions. So what is the product of 2xy divided by z and 3x squared divided by 4yz? To multiply rational expressions, follow a similar method to that for multiplying two numerical fractions. The domain is z cannot equal 0 and y cannot equal 0. Okay, so again, I had those variables in my denominator. They can't equal 0, otherwise my denominator would be 0, and I can't divide by 0. Okay, so I have 2xy divided by z times 3x squared divided by 4yz. So I just multiply straight across. So multiply the numerators by the numerators and the denominators by the denominators. Break down into its smallest components. It's usually helpful to write out the prime factorization of the numbers to help find common components. Okay, and then we can reorder them so they're all in numerical and exponential order. Okay, and I can divide out my common factors. They both have a 2 in common. They both have a y in common. Everything else stays the same. So whatever I have left over, that's going to become my simplified version. So I simplify what's left, multiply all the terms left in the numerator and all the terms left in the denominator. So I have 3x cubed divided by 2z squared. What is the simplified form of 5x divided by x plus 3 times x squared plus x minus 6 divided by x squared plus 2x plus 1 times x squared plus x divided by 5x minus 10? So again, I factor all my expressions as much as possible. 5x and x plus 3 are simplified already, but x squared plus x minus 6 becomes x plus 3 times x minus 2. X squared plus 2x plus 1 becomes x plus 1 times x plus 1. And x squared plus x, I can factor out an x, so I have x times x plus 1. And then 5x minus 10, I factor out a 5, so I'm left with 5 times x minus 2. Okay, and then I multiply everything together. So all my numerators together, all my denominators together. Leave them in factored form because this way you'll be able to cancel out factors that are common. Okay, so again, I'm going to divide out my common factors. They both have a 5 in common. They have an x plus 3 in common, an x minus 2 in common, and an x plus 1 in common. So whatever is left over, in this case, an x times x and an x plus 1 on the bottom, okay, is what is left over. So I get x squared divided by x plus 1. Multiply a rational expression by a polynomial. What is the product of x plus 2 divided by x to the 4th minus 16 and x cubed plus 4x squared minus 12x? So I'm going to put the polynomial that is just a polynomial over 1 to make it a fraction. And then I multiply just like I normally would. So what I'm going to do again is I'm going to factor as much as possible. So x cubed plus 4x squared minus 12x becomes x times x plus 6 times x minus 2. X squared, x to the 4th minus 16 becomes x squared plus 4 times x plus 2 times x minus 2 when you factor everything out. Step 3, again, I multiply my numerator by my numerator and my denominator by my denominator. Okay. And now I'm going to cancel out my common factors. Okay. So in this case, x plus 2, x minus 2, and there's no other common factors. We also know that the domain is negative 2 or positive 2. Okay, so if I set each of these factors equal to 0, so x squared plus 4 equal to 0, I get x squared equals negative 4. So square root of that is x equals plus or minus 2i. Okay, but you're only dealing with real factors at this point. So the x plus 2 and the x minus 2 give us my factors for my domain that makes it equal to 0. Okay, and then I simplify what is left. So I have an x plus 6 on the top, an x squared plus 4 on the bottom, and a 1. Okay, so that gives me x times x plus 6, and then x squared plus 4. So again, multiplying rational expressions, when multiplying fractions, multiply the top by the top, bottom by the bottom, and then cancel factors. The goal is to make 1. Okay, so if I had x cubed minus 4x divided by 6x squared minus 13x minus 5 times 2x cubed minus 3x squared minus 5x divided by 3x cubed plus 7x squared plus 2x. Okay, I would do all my factors, then cancel out the common ones. Okay. You can, of course, leave them with just the factors, so just x plus 1 over 3x plus 1, or you can multiply through if you had multiple factors. Okay, and again, I'll get these. X can equal negative 1/3, 5 halves, or negative 2. Divide rational expressions. What is the quotient of x cubed plus 3x squared plus 3x plus 1 divided by 1 minus x squared and x squared plus 5x plus 4 divided by x squared plus 3x minus 4? So you're going to follow the keep change flip method, or the KCF method. You're going to keep your first fraction or first number the same, change your division sign to a multiplication sign, and flip your second fraction. This is also called multiplying by the reciprocal. Okay. Step 2 is to factor both fractions as much as possible. Okay. So now that I've done that, I'm going to follow the same exact steps that I did when I was multiplying. Okay. I multiply the numerators together and the denominators together. The domain here is, this is what I'm looking for. So once I do that multiplication step, whatever that domain is, that's whatever is on your denominator, that's what your domain is going to be. So x plus 1, x minus 1, and x plus 4 give me a domain where x cannot equal negative 4, negative 1, or 0, or 1. Step 4 is to divide out my common factors. So they both have an x plus 1, an x minus 1, or another x plus 1, an x plus 4, and an x minus 1 in common. Okay, then it's whatever is left. So in this case, x plus 1 is left on the top, and the minus sign is left on the bottom. So that gives me x plus 1 over negative 1, or negative x plus 1, which you can also multiply through to get negative x minus 1. Either of these answers would be acceptable. Okay, so again, dividing polynomials, very similar to what you did with multiplying. You're going to flip, when dividing fractions, flip the second fraction, factor, and then cancel out common factors, just like with multiplying. Okay. Use division of rational expressions. A company is evaluating 2 packaging options for its product line. The more efficient design will have the lesser ratio of surface area to volume. Should the company use packages that are cylinders or rectangular prisms? So option 1 is a rectangular prism with a square base. So it has side lengths of 2x. Option 2 is a cylinder with the same height as the prism and a diameter equal to the side length of the prism's base. So the diameter is 2x, so the radius is going to be x, and its height is 2x. Okay, so I find the surface area of the rectangular prism. The formula for surface area for rectangular prisms is 2 times height times width plus length times width plus width times length. Okay, so I just substitute those values in. Okay, I get 2 times 4x squared plus 4x squared plus 4x squared, which is 2 times 12x squared, or 24x squared. I find the volume of the rectangular prism, which is just length times width times height, which gives me 8x cubed. Then I can determine the ratio of the surface area to the volume, which is 24x squared divided by 8x cubed. Okay, again, surface area, volume, and simplify it, which gives me 3x, 3 divided by x. Okay, I do the same thing for the cylinder. I find the surface area, which is 2 pi RH plus 2 pi r squared. I substitute the values in, and I get 6 pi x squared. I then find the volume, which is pi r squared h. Again, I substitute my values in, and I get 2 pi x cubed. Now I'm going to do the same thing and determine the ratio. So surface area divided by volume, which gives me 3 divided by x. In this case, we can compare the ratios. We can see that the prism and the cylinder both have the same ratios, which means that the company is going to have to use some other criteria to figure out what their package design needs to be. Summary. So in conclusion, again, when I'm multiplying and dividing ratios, I multiply numerator by numerator, denominator by denominator, find my common factors, and factor them out. Okay. Dividing, you'd have one additional step on top of that. So when you're dividing fractions, you keep your first fraction, change your division sign to a multiplication sign, and flip your second fraction. It's also called multiplying by the reciprocal. You also want to find your domain, which is always going to be based off of your original expression. So when you're multiplying, it's just your whatever your denominator is at that time. For dividing rational expressions, it's whatever happens after you flip the fraction. And that is the end of Unit 4, Lesson 3.